Good morning, students. Myself, Vijay Shankar from ECE Department, Cherburg Engineering College. Today, we are going to discuss about the examples in the magnetostatics. That is the fourth unit. In the last class, also we discussed some examples. Now you can see the remaining examples in the magnetostatics. This is the first example in the materials and the inductance of magnetic forces. Say point charge Q is given minus 1.2 coulombs, has velocity v bar is equal to, in the Cartesian coordinate system, they given 5ax bar plus 2ay bar minus 3az bar meter per second. Find the magnitude of the force. Find the magnitude of the force. Means the F bar magnitude. They're asking find the magnitude of the force exerted on the charge if the electric field is given, electric flux or the electric flux, magnetic flux is given. And the third one, they're asking the both are present simultaneously. So individually they ask the force you have to find out when the electric field E bar is also in the Cartesian coordinate system, and B bar, the magnetic flux, what is the magnitude of force is exerted, and the third one is both are present simultaneously. What is the magnitude of the force exerted on the charge given minus 1.2 coulombs? The formula we have for the electric force exerted by the electric field on the charge Q is actually the force per unit charge. Force per unit charge is the electric field E bar. E is equal to F by Q, and F is equal to Q into E. If both are in the vector form, F bar is equal to Q into E bar. What is the Q given? 1.2 minus, and E bar is minus 18ax bar plus 5a by bar minus 10 az bar. Multiply this function with the minus 1.2, 18, 5 and the 10, we get 21.6 ax bar minus 6 ay bar plus 12 az bar. The force is in the newtons. Okay, F bar is equal. But they are asking that the magnitude of force exerted. So x bar coefficient whole square, 21.6 whole square, and ay bar coefficient minus 6 whole square plus, and az bar coefficient 12 square. You'll get the magnitude of electric field or the electric force exerted by the E bar. F bar is equal to 25.42 newtons. And similarly for the B, they're asking F bar is equal to Q into B bar cross B bar is a formula for the magnetic force. The magnetic force exerted by the B bar on the charge Q is the formula is Q into B bar cross B bar. What is the V given? This is a velocity 5ax bar 2ay bar minus 3az bar. It is not the multiplication, my dear students. It's a cross product. It's a cross of the magnetic flux B bar. So 5B bar, the velocity is given 5ax bar plus 2ay bar minus 3az bar, and the B bar is also given the magnetic flux minus 4ay bar, not the ay bar, ax bar plus 4ay bar plus 3az bar. Okay, and here it is a Q into B bar cross B bar. The cross product we know. It is in the Cartesian coordinate system, means you can write the ax, ay, az in the first row. The second row is the b coefficients, the b, ax coefficient, ay, and the az coefficient. That is, after multiplying the 1.2, they are directly given that it is a minus 6, minus 2.4, and 3.6. Okay, you can take this Q into V bar cross B bar. I multiplied here. Otherwise, finally you can, after applying the cross product, then you can multiply the Q also is the right answer. Okay. Now the minus 4, 4 and the 3. For AX, minus 2.4 into 3 minus 3.6 into 4. Okay. Cross multiply these two and minus of 3.6 into 4 for to get the AX. And to get the AY minus AY is equal to cross product is 6 into 3 minus 6 into 3 is 18 and minus into minus is a plus 4 into 3.6 that is a 14.4 and AZ bar means you can take these lines minus 24 plus 4 into 2.4 that is a 9.6. Finally get the FM bar is equal to FM bar multiplying the Q into V bar cross B bar, where V is the velocity and the B is the magnetic flux. And its magnitude we got the 40.1058. And the third one they're asking that the total force exerted by both the fields. In both the fields we have electric and the magnetic field. What is the force is exerted of the magnitude of F bar? F bar is equal to F bar plus Fm bar. So what is the formula we have? F E bar is equal to Q into the electric field E bar and F M bar is equal to for the magnetic Q into V bar cross B bar. V bar cross B bar. Okay. Now what is the Q into E bar? E bar is given. Multiply that one with the charge whatever we have. The charge is 1.2 minus. You'll get the coefficients of AX, AY, and AZ. Then you can add the two functions. F bar is equal to Fe bar plus Fm bar. The charge is multiplied with the electric field. We get the coefficients 21 and something. And Fm bar is equal to, this is a total function minus 21.6 AX plus 3.6 AY and minus 33.6 AZ. You can add the two functions according to that. AX bar coefficient add with this AX bar coefficient. 21.6 minus 21.6 is a 0 AX bar. And minus 6 plus 3.6. That is a 9.6. Sorry, it is not the plus, it is the minus here. Minus 6 minus 3.6 means you can subtract the value and 2.4 highest value is a minus, so minus 2.4. And 12 minus 33.6. So minus 33 minus 12 is a 21.6 AZ bar. So we have only the AY coefficient and the AZ coefficient. You can take the square of under root minus 2.5 whole square and minus 21.6 whole square. Its total magnitude is at 21.73. So individually find out the magnitude. We got the 40.1 and previously we got Fe bar also. Got it, my students? You have to remember the two formulas here. The Fe bar is equal to Q into E bar. Fm bar is equal to Q into V bar cross B bar, the cross product. Okay. The next example. So a conductor 6 meters long, a conductor 6 meters long along Z axis with a current of 2 amperes. Conductor is given with a 6 meter long in the Z axis or the Z direction with a current of I is equal to 2 amperes. That is also in the Z direction, the AZ bar direction. Find the force experienced by the conductor if B bar is equal. If B bar is equal. Okay. The force exerted on the current carrying conductor in the magnetic field, the formula we have it is F bar is equal to I into dl bar cross B bar. I into DL bar cross B bar. So actually the H bar is equal to, we have the formula is I DL bar cross B bar by the 4 pi, the function we have. And here the given function, the 6 meters long the length, and the current is 2 amperes, and the B bar is also given. So the formula related to the force exerted on the current carrying conductor in the magnetic field is given as F bar is equal to I into DL bar cross B. And I is in the 2, DL bar is along the direction, so 6 into AZ bar. They are saying it is in the Z direction. 6 AZ bar cross B bar. B bar is in the 0.08 AX bar. Okay. So 2 into 6, you can multiply here itself. The 2 into 6 is a 12 AZ bar cross 0.08 AX bar. Okay. Now I can find the AZ and AX. All the one term we have, the 12 into 0.8 is a 0.96. AZ and AX, the cross product of Z and X, is in the order. So the plus AY bar. Okay. X, Y, Z, the cross product of X and Y, you get AZ, and Y and Z cross product is a AX, and Z and X cross product will get the AY. If it is a reverse means, we'll get the negative sign. The 0.6 AX, AZ bar cross AX bar is equal to AY bar. Bar is equal to 0.96 AY bar. So in this example, we have the formula is F bar is equal to IDL bar cross B bar. In the previous example, we find the force exerted on the electric field Fe bar is equal to Q into E bar. And if it is a magnetic flux given, Fm bar is equal to Q into, if it is in the charge, Q into V bar cross B bar. Now here, I into the current, they are saying that bar is equal to IDL bar cross B bar. Got it, my friends? The next example, is a current element I1 delta L1 bar is equal to the two functions we have, I delta 1 or IDL bar. A small differential length we are taking here. Actually, it is a IDL bar. Okay. In that, the first one is a I1, a small differential length, IDL1 bar is equal to 10 power minus 5 AZ bar. Okay. And it is located at the point 1, 0, 0. And second one is a I2, a small incremental length IDL2 bar is equal to, given it is 10 power minus 5, all the coefficients are 0.6 AX bar minus 2 AY bar plus 3 EAZ bar. And it is located at the point of minus 1, 0, 0. Both in the free space. Both are in the free space. Find the vector force exerted on I2 delta 2 by I1 delta 1. Okay, the force exerted, vector force exerted. Suppose here the Q1 is already there. If you bring that is a Q2, the force is exerted on the Q2 due to the Q1. They're asking that find the vector force exerted on I delta 2, means here it is reduced. There is a force is exerted on I2 delta 2 due to the I1 delta L1. Okay, due to this, there is a force is exerted on the I2 delta. Got it, my students? So for this, the given functions we already have I1 delta 1 and I2 delta 2 with the located at the points 1, 0, and -1, 0. The magnetic field at the point P1 due to the I1 delta L1 can be obtained using Biot-Savart's law as follows. So the magnetic field intensity at point P1 due to I1 delta L1 can be obtained by using the Biot-Savart's law. So what is the Biot-Savart's law formula here? The differential H bar or the H1 bar is equal to, if I am writing it is a H1, so you use here I1 delta L1 cross AR12 bar whole divided by 4 pi R square. That R is R12 whole square. This is a formula for the according to the Biot-Savart's law of the magnetic field intensity at the point P1 due to the I1 delta 1. Okay. And what is the R12 bar is equal? R12 bar is equal. We have the AX terms only. Here it's a AX term and here it is a AX term. The two functions. The point P1 and the P2. X, there is no Y and the Z, and here also the X, there is no Y and the Z. So -1 to the -1. Okay. Here I2 delta 2 is a receiving end and I1 delta 1 is a sending end. So the point is here the 1, 0, 0. And this one is located at this point of 1, 0, 0. So -1, -1 into AX bar plus 0 minus 0 AY bar, 0 minus 0 AZ bar. There is no AY and the AZ. The R12 bar is equal to -2 AX bar. And its magnitude is a magnitude of R12 bar is equal to under root of -2 whole square. That is equal to 2. And we need the R12 bar also. The unit vector is R12 bar magnitude or the magnitude. Here we can take the vector first of all. And the denominator is the magnitude of R12. Is a -2AX bar whole divided by the R1 to the magnitude is a 2. So 2 to get cancelled. The -AX bar is a unit vector. Now I can substitute these all the functions in the DH1 bar. DH1 bar is equal to I1 delta 1, I1 delta L1. What is the value here? The 10 power -5 AX bar. Not the AX, sorry, it is a AZ bar. It's a AZ bar, my students. AZ bar cross -AX bar. What is the cross of AR12 bar? We got as -AX bar whole divided by 4 pi into R12 whole square. R12 is a magnitude is a 2 whole square. Got it, my students? That is equal. We have only the two functions here, the 10 power -5. 10 power -5. AZ bar cross -AZ bar is a Z and X is a AY. The cross product is a AY bar whole divided by, here the 4 is a 16 pi. And already the minus is there, we have the minus. Okay. Now we got DH1 bar is equal to -10 power -5 AY bar 6 divided by 16 pi the ampere per meter. The DH1 bar is equal. Okay, and thus we can find out the dB1 bar is equal to the differential magnetic flux is equal to the relation is there, the mu naught into differential H1 bar. The mu naught, what is the mu naught we have? 4 pi into 10 power minus 7 multiply with minus 10 power minus 5 AY bar whole divided by 16 pi. So 4 pi with it is here the 4 and 10 power minus 7, 10 power minus 5 is 10 power minus 12, and here the minus is there, minus 1 by 4 is a 0.25 into 10 power minus 12 AY bar. It is a differential magnetic flux. Ampere, this is an ampere per meter, this is a Weber per meter, or this is a Tesla. We got the differential magnetic flux also. So finally, what they are asking here, to find the vector force exerted on I2 delta 2 by I1 delta 1 is given by here. Now it is a F2 bar is equal to the force is here itself. Here the force F2 due to the I1 delta 1. So I1 delta 1 F2 bar is equal to I1 delta L1 I2 delta 2 the cross of dB1 bar. This is a formula for the F2 bar is equal. So what is the I2 delta 2 given? 10 power minus 5 multiplied with minus 0.6 AX bar minus 2 AY bar plus 3 AZ bar is I2 delta 2 is given. Now the cross product of dB1 bar. What is the dB1 bar is given? It is a we got minus 0.25. Sorry, here the 0.25 1 by 4 is 0.25 into 10 power minus 12 AY bar. Okay. Now to apply the cross product here, that is equal to 10 power minus 5 here and 10 power minus 12. Totally, it is a 10 power minus 17 multiplied with the AX AY cross product is a AZ. So minus 0.6 and 0.25 minus 0.6 and minus 0.25 multiplied X cross AY is a AZ bar. Okay. Then again minus into minus here the plus 2 into 0.25 means 1.5 you get 0.5 so 2 into point let us take it is a 2 into 2.25 AY cross AY is equal to AY cross AY is equal to we have we'll get here the AY cross AY means nothing but it is a 0. Then after minus 3 into 0.25 3 into 0.25 AZ cross AY is a reverse, so it is a minus and the AX bar. Got it, my students? Then after it is a 10 power minus 17 multiplied with we got a minus 0.6 and minus 0.25. It is a plus 0.15 AZ bar, and here the plus AY bar cross AY bar is equal to, we got it is a 0, my dear students, and 0.25 into 3 as of 0.75 AX bar. 0.75 AX bar. Got it, my dear students? So finally, the force is vector force exerted on I2 delta 2 by I1 delta 1 value is F2 bar is equal to 10 power minus 17 into 0.6.25, it is 0.15 AZ bar plus 0.75 AX bar. Got it, my dear students? Okay. Sorry, here it is a minus 0.6, it is a plus only, my dear students. It's a plus, then we will get out, here is a minus. Okay. Coming to the next example, calculate the inductance of a solenoid of 200 turns wound tightly on a cylindrical tube of 6 centimeters diameter. The length of the tube is 60 centimeters and the solenoid is in the air. We know the inductance L is equal to, whenever if it is given in the solenoid, means the length of the solenoid is a L. The formula of the inductance to find the solenoid with the length L is a mu n square A by L. Mu n square A by L. See the given functions. Given function is a mu. The mu r is equal to 1 because it is a 8. Mu r is equal to 1. The mu naught is equal to 4.10 of minus 7. And given the number of turns is 200. And the diameter is 6 centimeters. Converted into the meters, 6 into the power of minus 2. And r is equal to, and we can write in the radius, r is equal to d by 2. So 3 into 10 to the power of minus 2 meters. And the length of the tube solenoid is 6 centimeters. Again, you convert it to the meters, 60 into 10 to the power of minus 2 meters. Substitute this in L is equal to mu as mu naught n square A. A is area of that solenoid is pi r square by L. What is a mu naught? The 4 pi into 10 power of minus 7. N square is a 200 given whole square into pi. The 3 in terms of the meters is a 3 into 10 to the power of minus 2 meters. So whole square and whole divided by the length, the 60 into 10 to the power of minus 2, that is also in the meters. Calculate this function, and finally we got the 2.36 in 10 to the power of minus 1 Hern. EL is equal to. Okay. So by using this further, mu is equal to n square A by the L. Here only you can remember that the diameter and the length is given in terms of the centimeters, and Weber per ampere meter. This mu is in the Weber per ampere meter. So you can convert these into centimeters as a meters. The L will get. Got, my students? And next example is a coil of 500 turns is wound on a closed iron ring of mean radius 10 centimeters and the cross-section area of 3 centimeters square. Find the self-inductance of winding if the relative permeability of iron is 800. Given here the relative permeability mu r is equal to 800, and A, the area is given, the cross-sectional area 3 centimeters square, converted to the meter as 3 into 10 to the power of minus 4, and R is also the given, that R is equal to the mean radius is 10 centimeters, converted to the meters, because it is a ampere meter will get in the mu and the mu naught. N is equal to 500. So what is the inductance formula now? The mu into n square A by Here given it is a closed iron ring. So 2 pi r cross sectional area. The 2 pi r mu is a mu naught into mu r. Mu naught we already know the 4-point number of minus 17. And the relative permittivity of iron is given the 800, right? That is 800. And n square, the 500 square. And the area already directly given, that is a 3 into the power of minus 4 in terms of the meters. And divided by 2 pi r. The 2 pi, the r is given the mean radius 10 centimeters in terms of the meters is a 10 into the power of minus 2. Calculate that one. You'll get the inductance L is equal to 0.12 Hz or 120 millihertz. Got it, Magnetostatics?